Welcome to the Tech Study channel. In the previous class, we have seen uh, fifth question and its answer of a Triboli subject. Then, in this class, we will see sixth important question and its answer. Sixth important question is explain the full wave rectifier with capacitor filter. So, first we will see uh, these topics. Full wave rectifier topic is related to the transformer. Okay, so what is transformer we will see first. So transformer is a static electric component that transfer electrical energy between two or more circuits via magnetic induction, changing AC voltage levels, means increasing or decreasing voltage levels. Okay, then we will see what is rectifier and what is full wave rectifier and what is filter and what is capacitor and what is capacitor filter, and then its working, and some other topics also. So first, what is rectifier? Rectifier means the electrical device that converts AC, means alternating current, which flows back and forth, to pulsating DC, direct current, which flows in only one direction. It is denoted by symbol diode. So AC, what is AC and what is DC? We will see now. Then AC. AC means that changes magnitude over time, means have frequency. And DC current means does not change magnitude over time and flows consistently over time in one direction and does not have frequency. Here are the graphs. This is for alternating current and this is for direct current. Mm, the graph is in between time and magnitude. Okay. Uh, so the AC current changes with the magnitude of AC current changes with time. The magnitude of DC current does not change with time. Okay. Then we will see uh, full wave rectifier. Okay. Full wave rectifier means it converts alternating current to pulsating direct current by using both half cycle of the input AC voltage. So here AC to DC it will convert for both half cycles of the input AC voltage. Means half cycles means what? Half cycle means we have positive half cycle and negative half cycle. So they are represent like this. And one half cycle, one cycle is the combination of positive and negative half cycle. Okay. Then Then it uses two diodes in which one conducts during one half cycle and while other conducts during other half cycle. Okay, it has two diodes, means we can understand diagram easily. Through diagram we can understand easily. So for positive half cycle and negative half cycle, I have drawn separate diagrams. So here D1 diode is there and D2 diode is there. So in the definition we have seen, it says that the diodes the one conducts during one half cycle and other during other half cycle. Means D1 conducts during positive half cycle and D2 conducts during negative half cycle. Conducts means what? Means current flows through the D1 diode, and in the negative half cycle the current flows through the D2 diode. Okay, so we get the output as D1 and D2, and combined output will be D1 and D2. Okay, then the current being always in same direction through RL load. The current direction is same through RL load. Here also, here also. Okay, then we will see what is filter. Okay, filter means it allows desired DC frequencies to pass through while blocking unwanted frequencies AC. Okay, so where this filter will be used means in the RPS, means regulated power DC power supplies. Okay, I will show you the diagram of it once. Here it is. So here transformer is there, and then rectifier is there, then filter, then voltage regulator, then output. Okay, so uh, rectifier we have already seen. So filter, what this will do means rectifier output contains rectifier. What is the work of rectifier? It converts AC to pulsating DC. But it is pulsating DC, not smooth DC. So to obtain smooth, stable DC, then we require a filter. So it blocks the AC. As I said, it blocks AC and only provides DC. Okay. So the rectifier output, contains DC component plus AC component. To remove this some amount of AC component from the output, we are using filter. So then we use voltage regulator, which is used to control voltage spikes, means up downs of voltage, and then we are giving to output. Okay, here the filter is of two types, capacitor and inductor. In this video we only discuss about capacitor. Okay, because the question is about full wave rectifier with capacitor filter. Okay, then the diagram which I have showed here represents a regulated DC power supply. It illustrates that the process of converting a high voltage AC to stable DC voltage. Okay, stable and steady also. Okay, then the diagram shows that the DC is passed to the voltage regulator and AC is blocked. Okay, the DC is passed to the voltage regulator and AC is blocked here. Okay, then it is either inductor or capacitor. We will see about capacitor. So a passive electronic component that stores electrical energy in an electric field. Okay, a passive electronic component that stores electrical energy in an electric field. Okay, acting like a tiny fast charging rechargeable battery. Hmm. It consists of two conductive plates separated and insulating material, separated by an insulating material. Okay, which is also called dielectric. Here is the capacitor diagram. These are two electrodes, and here negative electrons are there and positive charges are there, and there in between insulating material is there, and electric field also there, and the current direction is through the positive to negative, and electron flow is through negative to positive terminal. Okay, then what is electrical charge here? In capacitor means potential energy stored within an electrostatic field. Means the charges are not moving. They are static, means stable. So we calling it as a electrostatic field developed between two conducting plates. These are two conducting plates separated by an insulator. Okay, then capacitance formula is Q by V. Q is charge and V is voltage. It is the amount of charge developed per unit voltage. Okay, then units of capacitor, that is equals to farad denoted by F, and electric field, invi- invisible region, a force surrounding a charged object. Means invisible region, a force surrounding a charged object. So the electric field is a invisible region surrounding area around a charged object, electron or proton. Okay, then capacitor filter. So it is an electronic device, electronic component used in power supply to convert pulsating DC into a smoother, steadier DC voltage. Here it is converting pulsating DC into a smoother, steadier DC voltage. Okay, from a rectifier, this DC pulsating DC will be from rectifier only. So here we can see that here the solid lines are representing filtered DC, and pulsating DC is represented by dotted lines. Okay, so here we can observe the difference. The ripple is reduced, means the unwanted AC signal is, the AC component is reduced from the rectifier output, which provides pulsating DC. Okay, so here pulsating DC, what it contains means it contains some AC component along with the DC component, which provide actual power to the load. Okay, DC component is providing actual power to the load. So pulsating DC, which is the output of the rectifier. Okay, it contains some AC component along with DC component which provides actual power to the load. Here we have load, capacitor, and D1 and D2 are is used as rectifiers, and then transformer. A transformer plus center tapped full wave rectifier plus capacitor filter. Then, so as I said, why it is called the rectifier output is called pulsating DC means because the rectifier contains some AC component also. That's why it is not steady, it is pulsating like like uh, like this. Okay, then we will see working of a capacitor filter. Okay, when the rectifier output voltage increases means here the voltage from these two diodes is increases, the capacitor charges rapidly to the peak voltage Vm of the input. Means this is also called charging. Okay, so charging means when the rectifier output voltage increases. Means I have shown in the diagram, you can understand by diagram that so the rectifier voltage is increases means the diode and diode, the voltage from diode 1 and diode 2 is increasing, so the capacitor charges to the peak voltage Vm, that is denoted by Vm. Here it is there now, capacitor output. It is the rectifier output, not input. This is the rectifier output. So the rectifier voltage is increasing means the diode D1 and D2 voltages are increasing and are given to capacitor. So this represents the same now, so it is increasing like this. So here also in the capacitor output also the capacitor charging to its maximum peak voltage. Okay, here I have shown here capacitor voltage, the area, charging capacitor. Okay, then this is called charging of capacitor. Okay, then we will see discharging. Discharging means when the rectifier output decreases. Here it is there, when the rectifier output is decreases, the diodes turn off. Here the two diodes will turn off. The capacitor discharges slowly through the load. So the capacitor discharges up to a certain point, not become zero. So through the load means it discharges to the load. Okay, then because the capacitor holds its charge, it prevents the output voltage from dropping to zero. Because between two, we know that a capacitor has two conducting plates and which contains positive and negative charges. One contains positive and another contains negative charges. uh, so in between them the electric field will be there. It will be always will be there. So here the wave is starting from this point, not this point, because it holds charges. The capacitor already holds charges. Okay, so the voltage is starting from this point, not from zero. Okay, and it increases when the diode and when the diodes are giving their voltages, increased voltages. Then they are decreasing up to a certain point, not zero, not to zero, because it holds some voltage. Okay, it does not completely becomes zero. Okay, then the output voltage remains relatively steady, significantly reducing the ripple, means pulsations. Unwanted AC component. Ripple means unwanted AC component present in the pulsating DC. Okay, then capacitor is connected in parallel with the load. Here parallel with the load. Okay, then uh, here we can observe the difference between the rectifier output and a uh, filtered output. So we can observe that ripple is reduced, means the fluctuations are reduced. AC fluctuations are reduced. Okay, so here I have shown the graph is between input voltage and timer, and here also output voltage and time. Here time period is T by 2 for half cycle, and for charging and discharging T1 and T2 respectively. Okay, here ripple voltage peak to peak is also there. What is that? I will tell you now. So T1 represents capacitor charge time and T2 represents capacitor discharging time. Here T1 it is here. So the charging time of the capacitor, and T2 is here, the discharging time of the capacitor. Okay, and T by 2 of the total time period, including T1 plus T2, that will give us a T by 2. Okay, charging plus discharging time. And then we will see what is ripple voltage peak to peak. So it represents the small unwanted AC voltage fluctuations remaining in a DC output after a capacitor filter. So what is that? Here I will show you. This is the fluctuations, means up downs. The AC voltage fluctuations remaining in the DC output after a capacitor filter. And its formula is V maximum minus V minimum. Here is the V maximum, VM means peak voltage, and here is the minimum voltage. Okay, Then the difference between the maximum and minimum voltage levels of the capacitor charging or discharging cycle. Okay. And when discharging the voltage drops when discharging the voltage drops from peak by a small amount. So it is here we are discussing about this capacitor output. So here during the discharging, means here discharging, the voltage drops, means voltage is dropping from peak from peak by a small amount. This is the small amount. And when charging, same happens in reverse. Means here when charging, the voltage increases. The voltage increases by a small amount. Okay, from here to here. Okay, then this is known as the peak to peak voltage or ripple voltage peak to peak. Okay, then we will find uh, ripple voltage peak to peak for center tap full wave rectifier with capacitor filter. So we need a total time period, that is T by 2, charging time plus discharging time. Okay, then uh, finding ripple voltage peak to peak, we need the charge gained by the capacitor in charging time, that is Q is equals to VR, means VR of peak to peak, into C. How it came means, we know the relationship, capacitance relationship, that is here C is equals to Q by V. Q is the charge and V is the voltage. So if we rearrange this equation, we get Q is equals to CV. Okay, so in place of V, we have taken ripple voltage peak to peak. So why we have taken ripple voltage peak to peak means, during the charging of capacitor, during the charging of capacitor, the voltage varies, represented by ripple voltage peak to peak, because it is the difference between V max and V minimum. Okay, so that's why we have taken ripple voltage peak to peak. So we get the charge gained by the capacitor in charging time. Then we are finding, it is considered as 1, and we are finding the charge lost by the capacitor is Q is equals to IDC dot T. From where this equation will come means, so here T is T by 2 and IDC is average load current. So from where this equation is come from is fundamental current equation. From the fundamental current equation, where I is equals to Q by T, charge by time. So Q is equals to I into T, rearranging it. Then I we have taken as IDC, and T is we have taken as T by 2. So why we have taken IDC in place of I means, the capacitors discharges the capacitors discharging charges are stored in output. We all know this because we have studied here that the capacitor discharges slowly through the load. So the capacitors discharging charges are stored in the load only. Okay. Then why we have taken T by 2 in the place of T means since the capacitor is recharging twice every full AC cycle. So the capacitor is recharged twice every full cycle means this is I have shown you first in the starting of this class that what is one cycle, what is half cycle, positive half cycle and negative half cycle. Then it says that since the capacitor is recharged twice every full cycle AC cycle means these two way these two half cycles become one cycle. Okay, so how many times it is charging? Two times, 1 and 2. Then it only has a time interval of T by 2 to discharge through the load through the load. Okay, it means and the we are discharging twice and we are recharging twice. Okay, so the time will be halved. Okay, here we can see that we are discharging two times in one cycle. Okay, then by the principle of conservation of charge, the total charge delivered to the capacitor by the rectifier during charging is equals to the total charge removed from the capacitor by the load resistor RL during discharging. Okay, means we are equaling these two equations 1 and 2. So we get VR of peak to peak is equals into C is equals to IDC into T by 2. We know the formula T is equals to 1 by F. Then VR of peak to peak is equals to IDC dot T by 2C. So here we are substituting 1 by F. Then we get the IDC by F into 1 by 2C. That is VR of peak to peak is equals to IDC by 2FC. So we got the value of VR of peak to peak. Then finding voltage RMS of full wave rectifier with capacitor filter. Then its formula is so what is VRMS? We have to understand first. It represents the effective AC component remaining in the filtered DC output. Then the means the represents the effective AC component remaining in the filtered DC output. Okay, I will show this one. So due to AC component only, these fluctuations are there. So this represents the AC component. Okay, these fluctuations. Okay, then we are finding voltage RMS. Then its formula is VR of peak to peak by 2 root 3. That is equals to, we already know the VR peak to peak value from here. We have calculated just now. So we are substituting here into, we are reversing it by 1 by 2 root 3. So we get VRMS is equals to IDC by 4 root 3 FC. Then we will find ripple factor. Ripple factor formula is gamma is equals to VRMS by VDC. So we already know VRMS. Then VDC is equals to IDC into RL. We are substituting here. So, and denominator reversing it, then multiplying, we get gamma is equals to, means ripple factor is equals to 1 by 4 root 3 F into C into RL. Okay. Then we will see what are the advantages of it. Means full wave rectifier with capacitor filter advantages. So ripple factor, the fluctuation remaining on the DC output, as I have shown earlier now, and a larger capacitor reduces this ripple. Okay. And voltage improvement, the output voltage remains close to the peak value Vm of the AC signal rather than falling to zero like unfiltered rectifier. So this is nothing but saying that ripple is reduced. Okay. The output voltage remains close to the peak value. So here is the peak value now. The voltage is close to the peak value. It does not reaching zero. Okay. Rather than falling to zero like unfiltered rectifiers. Okay. Then in conclusion, what we have all understand is a full wave rectifier with a capacitor filter converts AC to pulsating DC by using diodes to rectify both half cycles, followed by a parallel capacitor that charges to peak voltage and discharges during gaps. And here this is called gap between two what we call rectifier output consecutive peaks. Between two consecutive peaks, it is filling the gap. Okay. Between two peaks of the rectifier output, it is filling the gap by discharging. Okay. And smoothing the pulsating DC into a smoother DC voltage. Okay. So that's it for today's class. If you feel this video is helpful, then subscribe, like, share and comment. I will see you in the next class. Bye.